All right, in this case, you can see we're just going to expand. If we put everything on the left-hand side, it would be greater or equal to 0. So I'm looking for some squares, but there are 3 kind of separate ones, the A, the B, and the C. So I'm going to have to use 3 different combinations, the A and B, the B and C, the A and C. And also, it looks like it's not just the product, it's A squared, B squared. And it's not just A squared plus B squared plus C squared, it's A to the power of 4, etc. So it's these squares. So let's start and have a look. So if I, instead of A minus B, if I started with A squared minus B squared, all squared, we know that has to be greater than 0 because we're using a real number all squared. And if I expand that, I do get A to the power of 4. I get B to the power of 4, but I also get minus 2A squared B squared. We know that's greater than 0. So we know that A to the power of 4, if I just rearrange, B to the power of 4 is greater than 2A squared B squared. So you can see what you're getting. I'm getting these two, and I'm getting 2 lots of that one. So it's looking good. I've definitely got some terms that I want. So if I say similarly, it's not going to write, so I'm going to write, there you go, similarly, and use the other combinations, so A and C. If I use A and C, that's going to be 2AC. And again, if I use B and A, no, I've used A and B, B and C, yep, that would be 2B squared C squared. So A and B, A and C, and B and C. So I'm using all 3. So again, if I have a look at this, you know, I want all of them. So why don't we just add and see what we get? Okay, let's add all these together. You can see we're going to get 2 lots of A to the power of 4s, 2 lots of B to the power of 4s, and 2 lots of C to the power of 4s. So 2 lots of A4s, B4s, C4s. And on the other side, we're adding 2 lots of A squared B squareds, A squared C squareds, and B squared C squareds. Alright, that's pretty much what we want, but we want to divide by 2. So if we divide by 2 both sides, I'm just going to do it like this, even though I shouldn't, then we'll get our answer that we wanted. So that's A. So remember, you can use A to do B, because it says, especially when it says hence. So how can we use this hence to do this one? Well, let's just be a little bit careful. So first of all, if I look at it, it does look like, you know, it comes from something squared, except we've got A squared B squared. So they're combinations of A's and B's this time, instead of just the A minus the B, or the A squared minus the B squared. So you might be able to recognize that if we start with something like AB minus BC, so we're kind of using a combination of A and C, but the B in the middle, so AB and BC. And if we square that, what happens when we do that? We will get our A squared B squared. We'll also get our B squared C squared. But we'll also get a negative 2AB squared C. So I'm going to put that on the other side. So we're going to get a 2AB squared C. I'm just putting that on the other side straight away. So you can see we are getting, because we've got all 3 letters in each of these. So this is how we get all 3 letters. Some are squared, some are not. We're going to kind of combine in the square term. So if I'm unsure, do a few trials of, you know, A squared minus C squared all squared, or you know, ABs, and maybe you picked ACs and just see what it looks like. So similarly again, my similarly is not going to fit. So similarly, if I choose, for example, B, C, and CA, and oops, I didn't do my working very nicely. So I should have said here, that's greater or equal to 0, and then expanded it out. Yes, which I didn't do very nicely at all. So for example, B, C, and CA. So I'm putting C in the middle, basically. Squared is greater than 0. Then I would have, in this case, BC squared. I would have, B squared C squared. I would have C squared A squared But I would also have a negative, and I'm going to put it on the other side, 2 ABC squared. And if I do the other one, so that was ABC, that was with the C in the middle, the B in the middle, so now I'm going to put A in the middle. So let's say BA minus AC squared. That's got to be greater than 0 because it's a real number. Here we'd get B squared A squared, we would get A squared C squared, and we'd also get a minus 2 A squared BC. I'm going to put it on the other side, so 2A squared BC. So I'm going to get those 3. So you can imagine what I do now if I just add them all, and I've written them weirdly, so I'll just write it over here. So if I add everything on the left side, I've got that, that, and that. So you can see I've got an A squared B squared here, but I've got an A squared B squared here. So there's 2 A squared B squareds. So there might be 2 of everything. 2. So we've got B squared C squared, B squared squeeze squared. C A C. So we've got A squared C squared. So we're getting 2 of each of those. And then on the other side, sorry, working so bad, I'm adding 2 lots of AB squared C, ABC squared, and A squared BC. So we've got A squared BC, B squared AC, and C squared AC. So they're putting the squared term first. But we would get that now if we just divide both sides by 2. So then we're going to get that. So that was all based on these squares being greater or equal to 0. So AB minus BC. So hopefully when you come across that again, you can recognize what we have to expand out. Now C says deduce that. So let's have a look at whether we're using our results, which probably we are, to do this. So it says deduce that if this, then this. If this, then this. All right. So you may want to start by looking at, because it says A plus B plus C equals D, and the only part that has D in it is over here, this ABCD. So let's just have a look at that for a second. So ABCD, let's use what they give us. So let's change that to ABC, and D would be A plus B plus C. That would be ABCD. So we've got A squared BC, we've got B squared AC, and C squared AB. Aha, that comes from here, doesn't it? From part B. So let's put a little thing here. So we know ABCD is equal to that. Now from both, now if we come back, we've got this A to the power 4 plus B to the power 4 plus C to the power 4, which is up here in part A. So I'm going to say from A and B at the same time. So our A to the power 4 plus B to the power 4 plus C to the power 4, we know from A that that is greater or equal to A squared B squared, A squared C squared, and B squared C squared. Okay, we already know that. But that in itself is in part B, that is greater or equal to A squared BC, B squared AC, C squared A, C squared AB. And we know that A squared BC, if you have a look at here, so this stuff here is actually equal to our ABCD. So since that, we can go back to here and say, well, that means A to the 4 plus B to the 4 plus C to the 4 has to be greater than ABCD. Okay, oops, I can't even write ABCD. I can write from this, since I put that there. Okay, I hope that helped.